Hi, I'm Bill Mold. I'm a bike mechanic and a wheel builder and a wheel engineer in Northern Virginia. And recently I hit on the idea of trying to build a bicycle wheel that would be strong enough to support a car. So here we have a 36 spoke wheel made with a velocity hub, a velocity rim, a velocity cliffhanger rim specifically, and a Maxxis tire, and it's all held together with 36 Supreme spokes. Of course, if I spin this wheel, it spins very well and would be phenomenally strong on a bicycle. The problem is, I have to figure out a way to attach this wheel to a car. The other thing I have to do is to figure out a way to have a stronger axle than I have in this wheel here. This is made, obviously, to go on a bicycle, so I have a 9mm hole going through the center of the axle. 9mm is not nearly enough to support the weight of a car on the wheel, so I have to figure out a way to remove this axle here and replace it with a stronger one. After I take out the bearing, so if I look at it this way, you can see that I've got a big hole which is a constant diameter. If I can make an axle go through that, a 22mm axle, and that obviously is going to make a much stronger axle to support the wheel than intended for the skewer. This is a generic hub. The bolt circle diameter here changes. Some hubs have 4 bolts, some have 5, some have 6. And now I have to figure out a way to attach this wheel to this hub. Some type of an adapter is going to be necessary to attach this wheel to this hub so we can put it on a car. And this is Brian Higgins, a senior graduating from Thomas Jefferson High School for Science and Technology in Northern Virginia. Brian is going to be a mechanical engineer starting next year. He's going to college. And Brian was my partner in this project, and his job was to build a bracket that would allow the wheel to be mounted to a bicycle hub. There was quite a lot of engineering, drawing skills required, as well as the design of the mechanical aspects of the hub, and it worked great. Here is the rear wheel of the Toyota Corolla that we used. This graphic here depicts the car's hub. That's the hub, and those are the bolts. And this is what Brian designed, a plate with a shaft welded onto it. The shaft has to be 22mm to match the internal diameter of the hub of the bicycle wheel. This graphic shows the car hub with the bracket slid onto it. The mounting bracket secured with lug nuts. My wheel slid onto the shaft. And if we cut some threads into the shaft, we can affix the whole thing in place with a lock nut. Here's Brian showing his invention in his hands. Tightening the lug bolts to attach the adapter to the hub of the car. Finishing that up, the adapter is now ready to receive the wheel that I built. Here is the wheel that I built attached to the adapter that Brian built, attached to the hub that Toyota built. In the next film clip, you'll see me lowering the jack to transfer the weight of the car onto the wheel, and you'll see that the wheel will do fine, but as the weight is transferred, at some point the tire is going to hit the frame of the car at the top of the wheel well, so we're going to have to change the tire. Alright, so we're going to now start lowering the wheel and transferring the load onto the wheel, and we'll try to get a sense of what's happening to the spokes by measuring the tension. Right now I'm getting a tension reading on that particular spoke there of about 3.7. So we'll measure that periodically and see how the wheel looks like it's behaving as more and more load is transferred to it. 3.5, so we still have a very large positive tension on that spoke. There's a little bit of pinging. Still got good tension there. Continue to lower the wheel. Also kind of getting a sense of how much tire pressure there is. That's kind of an unknown. I'm going to let a little air out. I don't want the tire pressure to go too high. And we'll load. Let me see. See, we've now transferred some considerable load to the wheel. And I think we're there, Brian.
Oh wait, the wheel well is getting really close.
Down here, you mean?
No,
Oh, up here?
yeah.
Oh, here. All right, but okay, but I think we almost have all of the, yeah, that's, yep, oh, you're right. You're right, it is. So let's see, that we may have to put a different tire on.
Yeah.
Here we are with a new tire that clears the wheel well, and you can see that all of the weight of the car has been transferred to the wheel. Now I'm going to get into the car and release the emergency brake and let the car start rolling. You'll hear a little bit of pinging, and that pinging is just the spokes adjusting themselves, and it does not indicate any weakness in the wheel. And after I get a little confidence in the wheel, after letting it roll a little bit, I'm going to get in the car, start it up, and drive it. The pinging will go away after about 2 revolutions of the wheel and not come back. Right. Woohoo! So there are a couple of takeaways from this experiment. First of all, obviously the wheel did its job and supported the car. The tire pressure was not an issue. I thought it might be, but it really wasn't. Another takeaway is that based on the monitoring I was doing of the spoke tension, I think that the wheel could have absorbed a much heavier weight than we put on it in this experiment. So I'd like to take this one step farther and find some people or a company that would like to partner with me and put 4 wheels on cars of increasing weight. We would need some brackets to attach the wheel that had various hole drillings in them, but somewhere between a Toyota Corolla and a cement mixer is the failure point of the wheels, and it would be very instructive to do some experiments and see just where that failure point is. So if there's anyone out there that would like to work with me on the science and engineering of a continuation project, I would love to hear from you. Here is all my contact information. Thank you for watching.